Hey everyone, how's it going? It's Tomasz here. Welcome to another episode of React Native. Today we are trying to implement a NFC reader/writer application both for iOS and for Android. Now you may or may not know, but writing a NFC chip wasn't possible up until iOS 13. But in September, Apple released the SDK, and now we can write the most popular chipsets with our iPhone. We are going to use a library called React Native NFC-Manager, which provides more or less convenient way of interacting with the most popular chipsets. I'm saying more or less convenient because the NFC chips that I bought are actually not yet fully supported. They provide a very low level API for manipulating the data on it, but there are no convenient API calls. But that's fine. That was actually pretty fun to research the protocol and figure out how to interact with this chipset. So I bought a couple of NFC tags from Amazon. Yeah, nice and colorful, and they only cost like £8 for 5 of them. So we are going to use these along with my trusty and slightly broken iPhone XS Max, because obviously you can't really use a simulator to test these kind of things out. Whatever we are writing should work on Android. I didn't personally test it because I literally can't find my only Android phone that has NFC capability, but I have to trust the developers and what they say that the functionality should work on on both platforms. Yeah, that's about it. This was enough talk, so let's get to the coding. Alright, first of all, sorry about the weird camera angle. I needed an angle where you can see my hands because it's gonna be a little bit of hardware manipulation. But yeah, let's do this. So I set up a new project. I called it React Native NFC Tutorial. I started Atom. I also have my phone hooked up here, and I'm sharing the screen using QuickTime. And yeah, alright, so as I said, we're gonna use React Native NFC Manager. The installation is super easy. npm install --save. So let's do that first. Yeah, so this might take a little while. So for Android, this is pretty much it. You just install the library with npm, and auto-linking take care of everything. For iOS, we're gonna need to do a couple of extra steps as per usual, because Apple likes to know things. Okay, so this installed, cd iOS pod install. Alright, and I'm gonna need to open Xcode, which hopefully won't crash my Mac OS, even though I have 64 gigs of RAM. Xcode tends to be pretty heavy. Alright, cool. So what I like to do first, usually if it's just a tutorial, I'm gonna get rid of the tvOS and all the tests, and I'm gonna nano my pod file here and get rid of all the test related stuff. Obviously don't do this if you do a production application, but for demo purposes this is perfect. Alright, so here in the README it points to actually an iOS library. So first thing we need to do is edit our info.plist in iOS, React Native NFC Tutorial, and add this. So basically you have to describe to the user why you want to use NFC. For demo purposes, I'm gonna leave it like this, but you know, obviously when it's production, please give an explanation why are you using it. And then what we need to do is under signing and capabilities, first of all you have to select your team, and then add the capability called near field communication tag. Cool. And this will generate like a provisioning profile and all sorts of stuff. One common thing is when I was setting up this project, my project name wasn't unique enough, and I guess other people are trying to do the same. And this needs to the bundle identifier needs to be unique across all of the users of the Apple developer program. So try to come up with something unique. Anyway, so we do have a project. So this is a brand new React Native project built with React Native in it. I don't like the boilerplate, so I'm gonna and my snippet doesn't work, but that's fine. Okay, so let's get rid of stuff. React component. I need safe array style sheet. I don't need scroll view. I need view text. I need text input, and I'm gonna use alerts and platform for sure, and that's about it. Okay, and let me change 2 spaces to 4 spaces. Replace all. Okay, cool. And I want to get rid of pretty much all of these. Okay, so I want to import NFC Manager and NFC Tech from React Native NFC Manager, and I want to do a class app extends component constructor props super props. I want to render return a view, actually safe array view style equals styles dot container. Okay, a bunch of boilerplate. Get rid of this, get rid of that. Container flex 1. Alright, so that's about it. Quickly just let's set up a interface. So I want to do a flex direction column and a justify content center. Okay, so I want a text input where the user can enter the text they want to write on the NFC chip. I want a write button, I want a read button, and I'm gonna have a text field for logging stuff out, right? Okay, so I need a text input styles.text input. I want on change text equals this on change text. Let me quickly write that. On change text equals this, we receive a text. This dot state equals, I want to log stuff and I want to have a text. This dot set state and just text. Okay, So on change text, auto complete type equals off. I don't want auto complete on auto capitalize equals none. Auto correct equals false. Place holder actually place holder text color equals 888, so dark gray, and place holder equals enter text here. Okay, that's it. I want a style for it. So margin left 20, margin right 20, height 50, margin bottom 10, text align, center, color black. Okay, cool. So that's that. I need a touchable opacity. On press. So this will be our write button. This dot write data. Write data equals and style equals styles dot write button write and I want the text style equals styles button text write text. I want the same for read button read, and I want to read data. While we are here, I'm gonna kick off a build on in emulator. Because this will take a while and might as well make the computer work for its money. Okay, so I need a bottom right. So I want pretty much these align items, center, justify content, center, border radius. I like when like to start with the design because it's better to work with something pretty than something ugly. Background color. Okay, so I'm cheating here, of course. So this will be our right button, and we're gonna have a same thing for read, but different color. So that's 006 C5B, and we need a button text which has a color of white. Amazing. How is our build going? Not good. Okay, so I also want to log something. View style styles.log text, and this state.log. Okay, and margin top 30, height 50, and these things. Okay. Let's see what's happening. Oh, it's still, no. I hate when this, oh, okay. Come on, this is just JavaScript, it shouldn't be this hard, just JavaScript. Cool, so we have enter text here, read write. Let me just do the log. Ready. Okay, cool. So here comes the fun part. All right, so the way things works is, so on component mount, component did mount, you have to start the NFC manager dot start, simple, and I'm gonna need a clean up method, and on component will unmount. I'm gonna go clean up. Okay, so in this cleanup we have to deinitialize a couple of things that I'm gonna explain in a second. Okay, so writing data. So first of all, if not, well, actually let's not do that first, but this state the text alert, and there's some text. Okay, but for testing let's ignore this for now and implement catch error, and on error I want to clean up, and this set state, and I want to log the error. Log will be error dot to string. Okay, all right, so the way NFC manager works is you have to pass in a kind of technology that you are using, that your NFC tag is using. Now, when I bought these NFC tags, I didn't really check what am I buying, but turns out I bought a chip which is called MyFair Ultralight, MyFair or MiFair, actually I have no idea how to say it, and turns out this kind of chip is not really supported with this library on iOS yet. Actually that's not true, it's supported, but you have to send very low level commands to it. But anyway, let's try to implement it. So first you need to tell the SDK what sort of tech are you trying to talk to. So let tech equals platform.os. If it's iOS, then NFC tech dot MyFair iOS. Otherwise, NFC tech dot NFCA. It's called differently. There is also MyFair. I haven't tried that, but anyway. Then actually this will be a async function, and this will be too. So then you do response is await NFC manager dot request technology tech, and here you can set a alert message ready for magic. So this alert message, you will see it in a second when I actually let me kick off the build for from Xcode, because this will take a while. But this alert message will display in the native iOS UI. You will see it in a second. But if you ever used Apple Pay, you see the pop-up coming. That's the UI you're gonna get. So this will actually take a long while. All right. So anyway, while it's building, so we are requesting technology, and then depending on the technology, you have different API calls through the library. Now, because I'm using MyFair, I don't really have much choice. I have to use a very low-level basic API call, which will be send MyFair command iOS, which basically is the low. You are sending byte commands to the API. So I was like, okay, I kind of have to order a new chipset, because there is no way I'm gonna figure out what sort of commands to send. But then I did some digging. I found my chipset type, which is NTAG 215, and I found some documentation on the NXP side, and I got to this 60-page document, which is pretty technical. It explains the whole memory structure of the chip, and I found the write command, and I'm like, wow, cool. Then a bunch of trial and fail, and finally actually figured out how to write the chip. All right, so in theory now the build is complete. Cool. Okay, awesome. So if I hit write, you can see this ready to scan thing, and if I touch it, nothing happens. Why is that? I have no idea. One thing I can think of is I have the entitlements. I have okay, I think I know why. Because I have to edit the scheme to be a release scheme. Well, I hope that's it. Otherwise, I'm just wasting your time. Okay, these builds are pretty long, so I might need to cut this out. Yeah, so when we are waiting, I'm gonna explain how write works. Essentially, on this chip, you can store 215 bytes of data, and these the storage is organized in 4-byte blocks, and they call them pages, and each page has an address. So you can send in a command starting with A2 in hex, followed by the address, the page address you want to write, and then there is a structure, a data structure that you have to follow. So you kind of have to tell what type of record you are trying to add. In our case, it will be text. So you have to define that this is a text record, and then you just send in your data. So each page page address starts from 2 essentially to 2C, and each of them contains 4 bytes. And yeah, there are some reserved sections. So for example, the third record is a big no-no to touch. I did touch it, and I actually for a second I thought I bricked one of my tags, but you can easily reset it back to normal. But yeah, yeah, this is what we are trying to accomplish. Oh, come on, dude. Alright, almost there. Cool. Yeah, hopefully. Nope, nothing. Let me try a different one. Oh, it actually says did detect tags. Okay, it's just because we are not writing, it doesn't say anything. Okay, cool. So I'm gonna reinstate this text thing because we don't want to write empty strings. And let's get to the nitty-gritty. Okay, so first of all, we need a command which will be if the platform.os is iOS, then it will be NFC Manager dot this. Otherwise, NFC Manager dot transceive. Okay, so we have a command. Let text this state the text. Okay. So the way this thing is structured is actually pretty complicated, but what you need to do is you're gonna do a resp await cmd, and you send in a array of bytes. So in the documentation it says you have to start with the command, which is a2, so 0x-a2. That's simple. Then you have to enter the address, which will be 04. Then you want to send in 0x actually, sorry. So 0x04 is page address, and then you have to follow it by 0x03 for some reason, and then you want a full length of the data, which we will figure out soon, and 0xd1 and 0x01, because you have to do that. Okay, so full length, that's full length equals text.length plus 7 bytes. Basically, all the decoration like explaining the engine that it's a text record takes 7 bytes. So you have to add for your text length 7 bytes. Then you have to define a payload length, which is text.length plus 3 bytes. And you can send it by resp. We already have resp equals await cmd. Okay, so again you want a write command, and you want to write the fifth page then you do payload length, followed by 0x54, followed by 0x02 and 0x65. Okay, the 65 is the correct, 54 is uppercase T, this is a space, special space, and this is E. Okay, so T space E. Then, okay, so you have to also write in the next page an N, and then you can start your data. I think EN is, so basically N and hello. And your payload. Okay, but you have to write full bytes. So let's do a iteration. So let current page equals. So the next page will be 6. Let current payload equals. So after this, I want to write 0x82 again to current page and 0x6e, which is a character N. Okay, but now we can start writing our text. So for let e equals 0, e less than text dot length e plus plus, current payload dot push text dot car code at. So get the ASCII character code at the position. If the current payload dot length equal 6, so if we have a full command, then resp equals await cmd current payload, current page equals plus equals 1, current payload equals again 0x82 and current page. Okay, and now current payload dot push. You always have to close your text with the character 0xFE, which is 254 in decimal. So you want to close it, and we have to pod the array to be 6. So while current payload dot length is less than 6, current payload dot push, and you just pod it with zeros, and then you do a thing, and I want to log this set state log resp.to string. Okay, so if all this goes well, then we wrote our string onto the NFC chip, and response should contain the number 10. Well, actually it will be 16. I mean, it's hex, but let's see if I didn't screw it up. And I did, because typo. Okay, stop. Again, on the simulator, unfortunately, you can't really test this, which is quite annoying. Alright, so in theory, so it says ready to scan, and nothing. Oh, I need to enter some text, and I also need a return statement here because we don't even want to. Oh, it actually wrote empty string. But all right, let's try this. Yo, hi. Okay, and I'm not sure if it wrote it. So I have this app called NFC Tools that's pretty useful for reading stuff. Oh, it actually wrote it, but I didn't receive the feedback. I'm not sure why is that, but yeah, it wrote it. So okay, so I'm gonna do a then print okay, so we can write stuff now. Hello. It's quite annoying that there is no feedback. When I did this test application, there was feedback. Oh, screen recording wasn't on. But anyway, so you can see here that I updated the record to be hello there. Okay, so now we just have to do the opposite with the read data, and that's pretty simple. So you do catch and basically you do the same. You do all this again, right? Okay, so for reading, the command is slightly different. So what we're gonna use is called what was it? Fast read. Yes, fast read. Basically, it receives free A as the command and a start and an end address. Okay. So let actually resp equals await cmd free A, and I just want to read the fourth page. The fourth page here, you remember, in the fourth page we store the full length. Okay, cool. So let payload length equals parse int resp to string dot split. So it will give you a comma separated, the toString will give you a comma separated list of decimals. Yeah, and then let payload pages is math.say. So the number of pages will be payload length divided by 4. So this is how many pages we have to read. Let start page equals 5. Let end page equals start page plus payload pages and -1. And okay, resp equals await cmd and 0x free A, and you want start page and page. So it will return a list of bytes as defined by decimal numbers. So let bytes equals resp.to string dot split. Okay, so now we have a list of decimals expressed as strings, and let's build our text. Let text equals, and for let e equals 0, e less than bytes dot length e plus plus. So I want to skip over a bunch of things. So if e is less than 5, continue. If parse int bytes I is equal 254. Remember, here we closed the string with 254. So if it's 254, then break this whole thing. Otherwise, text is equal text plus string from car code parse int bytes I. Okay, and this dot set state log text. Meanwhile, I figured why I don't have feedback. So when you request technology and you hit for some reason there is an error, you have to cancel the technology request. And the issue is that if you once screw it up, then it won't work until you restart your phone, which is super annoying. But basically you have to clean up like this. NFC Manager cancel technology request dot catch and this. Okay, so let's try to build this. Build succeeded. I actually haven't checked if okay, so if I hit read, see, you can see the last text we wrote. So yo, so we're gonna write it. That gives us success. Read it. It tells us yo. Alright, and I think that's about it. I mean, this is pretty much proof of concept. You can do a lot of things with this NFC technology. You can share links, you can give Wi-Fi access, you can do whatever you want. Right now the library for MyFair Ultralight is pretty limited. This document was a pain in the ass to understand, but once you understand it, it's pretty easy to follow. But yeah, like other kind of tags have much better implementation. So if you check their examples for NDEF, you can just do bytes equal build payload URL, write NDEF message, and you are done. But unfortunately I didn't really check what sort of chip I'm buying. Anyway, that's about it. Hope you liked this video. If you like, please leave a like, subscribe, leave a comment. That way I know you are watching. And yeah, see you next time.